Okay, so we talked about the Pythagorean theorem last time. That's one way to solve for missing sides of a right triangle. And today we add two more. They're special right triangles. One of them is called a 45-45-90. The other one's called 30-60-90, and they work in similar ways. Okay, so we'll start by talking about it with the 45-45-90 triangle. All they did to make that triangle is they started off with a square. Square, 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 90 degrees, 90 degrees, 90 degrees, 90 degrees. And if that's x, that's got to be x. If it's a square, all the sides are the same length. Then they drew in a diagonal, this diagonal y, which cut that 90-degree angle in half, which cut that 90-degree angle in half, which now made a 45-45-90 triangle. It's isosceles. If these two angles are the same, these two sides have to be the same. If that's x, that's x. Now we can just do the Pythagorean theorem to figure out what this diagonal has to be. Okay, so that's all we did here. We did x squared plus x squared equals y squared. X squared plus x squared equals y squared. That's all that we've done so far. Clean it up a little bit. X squared plus x squared is equal to 2x squared. So I have 2x squared is equal to y squared. I want to know what that y is, so I square root both sides, and I'm there. Now, I ran out of room right here, so I just came up here. And when I went from here to here, all I did was I just switched these around. So my 2x squared is right there, and my y squared is right there. Okay, so the square root of y squared is just y. And the square root of 2x squared, I can rewrite that as the square root of x squared and the square root of 2, because x squared times 2 is just 2x squared. And the square root of x squared is just x. So now I know that my hypotenuse, that y over there, is just equal to x times root 2. Now, the good thing is I don't ever have to do this again, because this thing just told me that my hypotenuse is equal to x times root 2. So whatever this x is, if this x is 4, then this piece, the hypotenuse, is 4 root 2. If this piece is 8, this piece is 8 root 2. If this piece is 204, this piece is 204 root 2. I don't ever have to do this again. So that's all we're going to put here. So if it's a 45-45-90 triangle, I call this one x, and this one is just x root 2, which you have on your formula chart right here. 45-45-90 triangle, 45-45, that's x, and that's x root 2. So now, how do we use that to solve questions? Okay, the issue I had last year is that they would give you an x on the page here, and then they would confuse the x on this paper with the x that's on the formula chart. They're not the same x's. So what I'm doing this year, and I'll do it on all the tests, quizzes, and everything, I'm just going to make all my x's a's. So instead of solving for x and y, I made that an a, and instead of having an x here, I just called it a. So now what I do is I labeled the three sides the same way it's labeled here. So these two legs are called x, so that's what I did. I said let this one be equal to x, and this one be equal to x, because that's what we just said right here. And the hypotenuse is equal to x times root 2. So this y, the hypotenuse, has to be equal to x root 2. So now if x is equal to 6, and a is equal to x, then I know a is already 6. Again, it's isosceles, so these have to be the same. So if this is 6, this has to be 6. And now this one says y is equal to x times root 2. But we just said that x is equal to 6. So my a has to be equal to 6, and my y has to be equal to 6 times root 2, because that's what it says right here. Y is equal to x root 2, and x is equal to 6. All right. So this one had an x right here. I just made it an a, and this one was y. So I wanted to know what a and y were, given that the hypotenuse was 14. So again, I go around the triangle and I labeled the three sides the same way I labeled it up here. My legs are both equal to x, so a has to be equal to x. My y is equal to x, and my hypotenuse, this 14, has to be equal to x root 2. So this is the equation that I want to solve to figure out what x is. So 14 equals x root 2, so that's what I put right there. 14 equals x root 2. How do I get this x by itself? I divide both sides by root 2. So now I get 14 divided by the square root of 2 equals x. But I said in class the other day, you cannot have a radical in the bottom and your answer considered to be simplified. So how do I get rid of a radical on the bottom? I multiply by, if this was a root 4, I'd do root 4 over root 4. If this was a root 8, I'd do root 8 over root 8. This is a root 2, so I do root 2 over root 2. Root 2 over root 2 is just 1, so multiplying by 1 doesn't actually change the value. On the top I get 14 times root 2, which is 14 times root 2. And on the bottom I get root 2 times root 2. Root 2 times root 2 is root 4, and the square root of 4 is just 2. So I got rid of the radical on the bottom. This 14 is outside the box. This 2 is not in a box, so I can actually do that. 14 divided by 2 is just 7, and that 2 stays in the box. So x is equal to 7 root 2. We wanted to know what a and y were. A and y, we just said right here, are both equal to x. And so if x is equal to 7 root 2, then a equals y, which equals 7 root 2. This one, again, I called that one a. This one is y. We want to know what both of them are. I go around the triangle again, and I labeled the 3 sides. So a is equal to x, y is equal to x. 5 root 14 equals, that's the hypotenuse, so it must be equal to x root 2. So this is the equation that I want to solve. So I have x root 2 equals 5 root 14. Divide both sides by root 2, and I get x is equal to 5 root 7. And we just said here that both a and y are equal to x, so a and y are both equal to 5 root 7. So again, this will save you a whole heck of a lot of time. Something else called the 30, 60, 90 triangle, which we have right next to it on the formula chart. Again, you don't have to memorize this, be familiar with it, know how to use it. This one we start out with an equilateral triangle. All the sides are the same, all the angles are the same. So it's 2x this way, 2x this way, and 2x this way. And all the angles are the same, they're all 60 degrees. Then we draw in this piece. We cut this angle in half. So now we create a 30, 60, 90 triangle. And if it was 2x all the way across, now it's just x from here to here. And I do the Pythagorean theorem again. A squared plus b squared equals c squared. So a squared plus b squared equals c squared. This 2x squared is 4x squared. So now I subtract x squared from both sides from here, and I get y squared is equal to 3x squared. I want to know what y is, so I square root both sides. Square root of y squared is just y. Square root of 3x squared, I can rewrite that as x squared times 3. The square root of x squared is just x, so y equals x root 3. So again, if I have a 30, 60, 90 triangle, I can do this all over again, or I can just remember this. That whatever my short side, so I'm going to have a short side, a long side, and a hypotenuse. Remember from last semester, smallest angle, 30 degrees, faces the smallest side. So this 30 degrees opens up and faces, this is called my short side. The 60 degree angle faces the long side, and of course this is always, the hypotenuse is always opposite the right angle. So my short side is always x. My long side, this piece, the one opposite 60, is always x root 3, and my hypotenuse is always 2 times the short side, which is all you're going to do here. So again, 30 degree angle is across from the short side, we call the short side x. The 60 degree angle is across from the long side, we call that x root 3, and the hypotenuse, again across from the right angle, is always 2 times whatever you have for your short side. So this is how quick they are. Let's say they give you this piece is 8, you already have all your answers. This piece is 16, and this piece is 8 root 3. Done. That's what's nice about these formulas, they save you a lot of time. Alright, so I did the same thing here. I changed all my x's to a's. That said x, I made it an a. And this said x, I made it an a. Okay, that's 60 degrees, so that means that's got to be 30. So again, I go around the triangle like I did on the 45, 45, 90s, and I label it the same way we have it labeled here. So my short side, the one opposite 30 degrees, there's my 30 degree angle. Opposite from that is my short side, that's x. It said it was 7, so 7 equals x. My long side, which was a, long side equals x root 3. And my hypotenuse always equals 2x. But I know what x is. 7 is equal to x. So my a is equal to x times root 3. X is 7, so a is equal to 7 root 3. Y is equal to 2 times x, but x is 7, so y is equal to 14. Again, done. The math has already pretty much been done for you in that formula. Okay, B, they were calling this one x, I made it a. And this is y, and this is 12 root 3. I go around the triangle, that's the 30 degree angle, and this is the short side. So a is equal to x. 60 degree angle, this is the long side, so y is equal to x root 3. hypotenuse always equals 2 times x. So I have 12 root 3 equals 2 times x. That's the equation that I want to solve. So I do it right there. 12 root 3 equals 2 times x. Divide both sides by 2. And I get 6 root 3 equals to x. So now we already got the a because we just said a is equal to x. And here we just said x equals 6 root 3. So if a is equal to x, then a equals 6 root 3. And we said here that y equals x times root 3. Y equals x, that's x, 6 root 3 times root 3. Root 3 times root 3 is 3. 6 times 3 is 18. So y is equal to 18. All right, one more. Same thing. If that's 30, that's got to be 60. I changed that x. I made it an a. Again, on the test homework, I'll already have that change made for you. You won't have to make that change. And I go around the triangle and I label everything. If that's the short side, that must be equal to x. This is the long side, so this must be equal to x root 3. And this piece, this y, is the hypotenuse. It equals 2x. Here's my equation that I want to solve. It says 9 equals x times root 3. To get the x by itself, I divide both sides by root 3, which gives me x equals 9 over root 3. Can't have a radical on the bottom. Multiply top and bottom by root 3 over root 3, which gives me 9 root 3 over 3. And then 9 divided by 3 is just 3. And I still have the 3 inside the radical box. So x equals 3 root 3. But we just said up here that a equals x, so then a equals 3 root 3. Y is equal to 2 times x, so y is equal to 2 times 3 root 3. So y is equal to 6 root 3. Done. Alright, these are a little bit more interesting. You'll see 2 of these on the test. I believe there's 2. You'll also see a bunch of these in pre-cal. So my sophomores who are doubling up, you'll see these. It's called a unit circle. You'll do a whole bunch of these next year. So the better you can get with them now, the better off you'll be next year. And those of you guys that'll take pre-cal in 2 years, well, this is a little heads up. Okay. It says I have a 225 degree angle starting here, and if you follow the arrow, it goes to there. Okay, so if it's 180 degrees in a straight line, so that straight line is 180, but they didn't stop there. They went a little bit more, and they said that they got to 225. So what did they have to add to this 180 to keep coming to get to 225? 45 degrees. So this must be 45 degrees. I then draw a line to hit the x from that point x-axis. So I create a right triangle. And if that's 45 and that's 90, that must be 45. Also, notice we just made a 45, 45, 90 triangle. Now, I label like I did a while ago. If it's 45, 45, 90, my two legs are both x. So that's x and that's x. Where does this 1 come from? Well, they're telling me, notice the location of that point, that's at 1. So the radius of this circle is 1. It's 1 from here to here. So this is also the radius of the circle, so this must also be 1. Hypotenuse is equal to 1. We just said on the back side, if it's a 45, 45, 90 triangle, the hypotenuse is always equal to x root 2. So I set x root 2 equal to 1. Divide both sides by root 2. You get x equals 1 over root 2. I can't have a radical on the bottom. Root 2 over root 2. So I get x equals to root 2 over 2. Now, you can do this every single time you get this picture, or you can just remember. If it's a 45, 45, 90 triangle, it's always going to be root 2 over 2. Now what they asked for were the coordinates of P. Coordinates have an x value and a y value. But we just said that this length right here is root 2 over 2. And we said this piece is root 2 over 2. So x is negative this direction, y is negative that direction. So my coordinates of P are negative root 2 over 2, negative root 2 over 2. Again, a lot more in class. Okay, there's 360 degrees in a circle. So they said that they started here, followed the arrow, they went this way, they came all the way there, and they went 300 degrees. So how much more would they have to cover to get to 360? 60 degrees. So that's where that angle is coming from. I draw a line from there to there, always to the x-axis, right angle. So if that's 60, that's got to be 30, and we just made a 30, 60, 90 triangle. And we said a while ago, the side opposite 30 is the short side, we call it x. The side opposite 60 is the long side, we call it x root 3. Just like last time, the radius is still 1, so this is 1. And we said that if it's a 30, 60, 90, the hypotenuse is always equal to 2 times x. So this is the hypotenuse, so 1 must be equal to 2 times x. Divide both sides by 2, and you get x is equal to 1/2. So this length is 1/2. We already got that piece. To get this piece, I got to take that x and multiply it by root 3. But x is 1/2. So 1/2 times root 3 is just root 3 over 2. Okay, so this piece is 1/2, and this piece is root 3 over 2. X is positive this way, y is negative this way, so the coordinates of that point are 1/2 negative root 3 over 2. A lot of examples that we will do in class.